Good everybody. We are all welcome to Jam Chemistry, tpaths Learning Center. We are so sorry for starting this late. So we are going to be talking about dwelling more on questions on atomic structure, electronic configuration, and the periodicity of elements. So this class is centered around a lot of basic subjects. Because you observe very well, these are questions that comes out every year, and we should all understand what this topic is all about. Fine, we all have knowledge about a lot of things, but today we will be solving questions on this concept today. So please follow me as we navigate through this topic today. So the first question we have there is the periodic classification of the elements is an arrangement of the elements in order of their. Now you need to know something. Now you look at the periodic table. The periodic table, you have your lithium, all starting from hydrogen, your helium in the far end, lithium, your potassium, lithium. Let us draw a rough sketch of it here. Hydrogen, helium, lithium, beryllium, you have carbon, nitrogen, oxygen, fluorine, and argon. So here we have sodium, potassium, rubidium, cesium, beryllium, magnesium, calcium, chromium, barium. We have carbon, silicon, germanium, tin, lead. We have nitrogen, arsenic, nitrogen, phosphorus, arsenic, antimony, bismuth, sulfur, selenium, polonium. We have fluorine, bromine, iodine, and platinum. We have argon, krypton, neon, krypton, xenon, radon. It's like a rough sketch of your periodic table. Now we have what you observe very well. We have something like this: 1, 2, 3, 4, 5, 6. If you can observe clearly from this periodic table, we have hydrogen 1, helium 2, lithium 3, beryllium 4, carbon 5, nitrogen 6, oxygen 7, fluorine 2. If you observe very well that these are what atomic numbers. So the way we can arrange these elements is based on their atomic numbers, and that is what the calculation is all about. You can observe the element arranged in increasing atomic numbers. We said that the nucleus of an atom contains dash. Now the nucleus of an atom, the nucleus. What does it contain? The nucleus contains two important subparticles. The nucleus contains two important subparticles. Please follow me. One of them is what? The proton. The first one is proton, and the next one is neutron. Proton, neutron. They are found in the nucleus. So to that question, they can see that the word proton only, no, that is not the answer. Neutron only, no, that is not the answer. Proton and neutron, that is a good answer. Please let's note, electrons are not found in the nucleus. They revolve around the nucleus. Let's note this. The electrons, they revolve around the nucleus. They revolve around the nucleus. We need to note this very well. The electrons revolve around the nucleus. They are not found in the nucleus. Let's continue. The third one, the size, open bracket, diameters of 5 atoms are in the order R less than T less than W less than Y. Y being the largest. So Y is the largest size there. Good. If each has an electron situated on its circumference and neglected that part of which of the atoms will lose its electron most reluctantly? That's a very good question. They are trying to ask us the relationship between the ability of an atom to lose electrons and its atomic size. Don't mind the English. Ladies and gentlemen, what do you need to do? You need to connect what you all know about ionization energy and atomic size. And what? Atomic size. You need to know something today, that the ability of an atom, or better still, the energy required for an atom to lose an electron is called ionization energy. To lose electron from its ground state to its gaseous state is called what? Ionization energy. And we need to understand ionization energy. And if you consider this periodic table, for instance, now, IE, let's put it here, IE, they will what? They decrease across the period. They decrease across the period, across. They decrease across the period. IE decrease across the period. They will now ask ourselves a good question. Then how does it relate with the atomic size? Ladies and gentlemen, let's look at the group. If you go down the group of hydrogen, lithium, sodium, potassium, rubidium, cesium, what do you observe? What you observe is that as you go down the group, the size of the atom keeps on what? Increasing. It keeps on increasing. And why does the atom increase? Why? Because the atom gains shells. There's an increase in the number of shells. New shells are being added. New shells are being added. New shells are being added. And that is why you see that the atomic size increases. We see that the atomic size will all increase. Now, if the atomic size is increasing, ladies and gentlemen, look, let's observe this. If the atomic size is increasing, that keep on doing that, I have an atomos shell electron here. We observe that the distance between this atomos electron here and the nucleus, as the atomic size increase, we will keep on what? Increasing. The distance between this electron and this nucleus will keep on increasing as you are adding new shells. New shells. So it will keep on increasing. What is the implication of it? What is the implication of it? The implication is that the attractive force between the nucleus and the atomos shell electron will keep on decreasing. Why will the attractive force decrease? It will decrease because the distance between the nucleus and the atomos shell electron is far away. Since the atomos shell electron and the nucleus, the distance between them is long. So therefore, you need to know that a little amount of energy will be required to what? To knock out that electron. A little amount of energy will be required to what? To knock out that electron. Therefore, we expect that atoms with the largest size should have the ease or to have high tendency to what? To lose an electron. So if you look at that question there, based on size, we can clearly see that Y is the largest. Y is the largest. Since Y is the largest, you can conclude that Y will have the highest tendency to lose an electron. We have the higher tendency to lose an electron. But the question is asking here, which of the following atoms will lose electrons most reluctantly? What does that mean? It means that which of them of that atoms will not easily lose an electron. The answer will be what? Will be the smaller size, and that is R. That is R. So R will not easily lose an electron. The next question, indicate that the following statement is not true as you move from left to right across the period, along the periodic table. A, atomic number of elements increases. Beautifully correct. That is correct. As I'm going across the period, the atomic number will increase. That is correct. The next one there, the positive character of elements increases. That is false. No, I will not accept that. Let's keep that one side first. And the negative character of elements increases. True. Electronegativity increases across the period. It increases across the period. Number of electrons in the atomos orbital of element increases. That is true. That's why you have period. Now, in period, you observe that as you go across the period, the number of electrons in the atomos shell will keep on increasing. So this is 1, 2, 3, 4. So you keep on increasing. So that's what happens there. So the answer to this answer is electropositivity. Electropositivity will decrease across the period, but will increase down the group. So the answer is what? Option C. Number 5. The following is an arrangement of elements in order of decreasing number of outer electrons. One of the elements is wrongly placed. What is it? Is that decreasing number of outer electrons? Decreasing number of outer electrons. That means we are trying to say that the first one, we have the highest number of electrons, followed by the next one. Decreasing number of electrons. That means if the first one is 5, the next one will be 4, the next one will be 3. So let's understand. Let's look at, we have also the expo here already. This is expo already. So, so this is group 2. I didn't write group 3. So boron, aluminium, gallium, indium, thallium. Thallium. That is group 3. This is group 3, group 4. So you can see clearly here, for instance, now. Aluminium, decreasing number of chlorine, silicon, magnesium, sodium. So aluminium here, we have three in the common shell. Chlorine, we have what? Chlorine, we have 1. Silicon, we have 4. Magnesium, we have what? Magnesium, we have 2. Sodium, we have 1. So 2, 1. So the answer should be what? In this question here, there are a lot of funny things here. Because if you have a silicon here has 4 in its outermost shell. Please understand the question here. So chlorine, sodium has 1, magnesium has 2. That's correct. There must be 3. What is 3 there? 2, 2, 1. No. Chlorine is what? 2, 5. After chlorine is silicon. So the answer should be aluminium. Because aluminium has 3. But aluminium is not placed first. So aluminium is placed first ahead. So the highest is what? Chlorine. After chlorine is silicon. After silicon is aluminum. Chlorine, silicon, aluminium. Backwards. Chlorine, silicon, aluminium. So chlorine has the highest number of atoms electrons, followed by silicon, followed by aluminium. But in that arrangement, we have aluminium first before chlorine. So you can say that aluminium is the answer. Aluminium is the answer. The next thing here, which of the following group of physical properties increases from left to right? We discussed about this today, but you can see we have introduced new terms here. IE, initial energy. You can see here it increases, it decreases across the period. It decreases across the period. So if IE decreases across the period, atomic radius will also what? Will decrease across. So sorry. IE increases. It increases, sorry. IE increases. So IE increases across the period. IE increases across the period. Electron affinity also. Electron negativity also. They increase across the period. Atomic radius does not increase across the period. It decreases down the group. So that question there, so it's not going to increase from left to right. So IE, number 1, number 4, number 3. 1, 4, 3. 1, 4, 3. We now have 1, 4, 3 there. So we can stick with what? Either 1 and 3, 3 and 4, 1 and 4. So 1 and 2, no. 2 must not be there. C, 3 and 4. The answer is C. 3 and 4, yes. Electron affinity and reactivity, they increase across the period. An isotope has an atomic number of 17. What is an isotope? What is an isotopy? Isotopy is a phenomenon whereby elements have the same atomic number but different mass number. I take that again. That isotopy is a phenomenon whereby elements have the same atomic number but different mass number. Element or species or substances that exhibit such thing is called isotopes. It's called isotopes. Now, we are told here that an isotope has an atomic number of 17 and a mass number of 36. Which of the following gives the correct number of neutrons and protons in an atom of the isotope. Now, we are told here, let's quickly clean this board. Please understand the question very well so you can answer it well. Now, we're told here, so it has atomic number of what? Of 17. Mass number 36. Mass number of what? 36. Now, if this is the atomic number, we need to know atomic number is the same thing as mass number. For a neutral atom, atomic number is the same thing as what? As mass number. It's the same thing. I need to recall that proton number, atomic number is the same thing as what? As proton number, proton number. You need to also recall that proton number plus neutron number is equals to mass number. 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 So if the atomic number is 17, we can conclude that the proton number is also 17. The proton number is also 17. Proton number is 17. Proton number is 17. The neutron number will be what? That will be 17 minus, 36 minus 17. 36 minus 17 is 19. 19. So this is 19. This is 19. Let's look at the question there. So neutrons is 19. Proton number is 17. So you can say the best option, let's answer that question is what? Is option C. Option C. An element Z contain 90% of 16.8 Z. Aha. This is a very, very good question. A very common question in JAM. Very, very common question in JAM. Let's do that together. Let's do that together. We're told that an element Z contain 90% of 16.8 Z. So 16.8 Z, 10% of it, 90% of it, and 10% of 18.8 Z. First of all, guys, when we see something like this, Z 18.8. 18 there means the mass number. Please let's know this. In case you see something like this, 18 there means the mass number. 8 there means the atomic number. So this, you are now asked here that what is the relative atomic mass? So the relative atomic mass, which is known as RAM, is equals to, the first one is 90%. That will be 90 over 100 times 16 plus 18 over 100 times 10 over 100 times 18. So do it mathematically, we will get the what? The correct answer. So let's do that mathematically. So this is how we do it. So why is we getting the RAM? The RAM is helping us to get the atomic number of the what? Of that species, of that element. So what do? Is that you is the percentage. So you find the percentage of the mass number plus the percentage of the mass number for the two different isotopes. So add them together, you get the RAM. Let's do it mathematically quickly. Because of in the exam, don't wait. Don't believe for calculator. Do this. 2 in 10, 5. 2 in 16, 8. 2 here. We have, this is what? 1.8 plus 9 times 8 is what? 72. 72 over 5. They can quickly, like I easily punch your calculator now to get the answer. Your calculator now should help you. So the answer is 16.2. The answer is 16.2. Let's look at the option here. Let's look at the option there. Let's look at the option there. 16.2 option B. The answer is there. option B, 16.2. Now we do go on like that. So expect things like this, expect them. He said, which of the following elements will form an oxide, which will dissolve in both HNO3 and NaO in solutions to form salt. Beautiful. Ladies and gentlemen, look at me. Look at this periodic table you have here. I want to state something today, and I want each and every one of us to note this down. That if you look at this, let me write this properly. If you look at this periodic table, this portion is the s orbital. This portion is the p orbital. What does it mean? It means that the outermost shell electron of the valence electron of the element found here are found in the s orbital. They are found where? In the s orbital. While the outermost shell electron here are found in the p orbital. The outermost orbital electrons are found in the p orbital. That is why you have them in the p block. This is what the s block. We have the p block, the tangential element, and we're not talking about that. This is what I'm facing today. Now, what is the nature of this oxide? We need to know about the nature of oxide. First of all, group S block element, they form basic oxide. Please, let's know this. In your book, don't joke with this. S block forms the form of basic oxide. While P block forms acidic oxide. Acidic oxide. Yes. So if you see many of the oxides formed in P block, they are acidic in nature. While for S block, they are basic in nature, but they are specific elements in S and P orbital that has the ability of showing both character. They can act as a base or an acid. That is, they can both give an acidic base or a basic. They can both act as an acid or a base, and such behavior is called amphoteric. Amphoteric oxide. Amphoteric oxide. And what are examples of elements that can exhibit such character? Zinc, although zinc is not there, zinc, aluminium, germanium. Very, very common. Zinc, aluminium, germanium. A very good example of aluminium is Al2O3. Al2O3. That is aluminium oxide. Aluminium oxide is a popular example of an amphoteric oxide. Very, very popular. Very, very popular. So, Al2O3 is a very popular example. So you can see from that question, the aluminum is there. Aluminum is there. So that is option A. Which of the following physical properties decreases across the periodic table? You see, increase, decrease. That is why you need to know about the trends. And you've seen so far today, you've been able to talk about the trend over and over again. Over and over again. I have reasons for that because it comes out very, very well. We need to know the trends. So let's look at that question there. What are the following physical properties decreases across the periodic table? Analytical potential, IE increases. Abi, EN increases. EA increases. Atomic radius does not increase across the period. It's what? It decreases across the period. So we've said that over and over again today. Let's note that the energy change accompanying the addition of an electron to the gas atom is called, beautiful question. Listen very well there. The energy change accompanied by what? Addition. That is gaining. Gaining of an electron is called what? What is the answer? Electron affinity. Electron affinity. Electron affinity is the energy to gain. While IE is the energy to what? To lose. Those two energy, you need to know about them very, very well. Next, we need to consider method there, development. Now let's talk about the development. You can see that question there, the word there. Millikan's 48, Millikan's contribution to the development of atomic theory is the determination of dash. Let's go through some things from the beginning. From the beginning of all the development, it all started from the fact that we all learned that John Tautin said that the atoms are indivisible, small indivisible particles. Yes, he said that. Beautiful, he said that. Then we now observe that some experiments were done afterwards. The first one was started by J.J. Thomson. And J.J. Thomson was able to do one thing, was able to discover what they call the electrons. Yes, J.J. Thomson discovered the electrons, but J.J. Thomson said one thing there. So now, guys, we need to understand what J.J. Thomson was able to discover the electrons of an atom. Yes, he did that. He also contributed something. Now, ladies and gentlemen, you need to know something about the atom. You need to be able to sit down and know each contributions of each scientist. What did they add to the contribution of the world, of the making of the atom? And J.J. Thomson, we can start from there. J.J. Thomson was telling us that what the atom, it told us about that there is what the presence of an electron. Yes, but he told us one thing, that J.J. Thomson was able to discover something. It's what they call the charge to mass ratio. The charge to mass ratio of an electron. He did that for us. He told us the charge to mass ratio of an electron. Yes. The next thing again was the fact that he concluded and said that the atom is a soup of electrons. The atom is a soup of electrons. And that model was called the plum pudding model. So you can be asked or it can be tested that who gave the model, who gave the plum pudding model? Please and please. The answer is J.J. Thomson. So after J.J. Thomson did that, he observed next was a scientist called Ernest Rutherford. Ernest Rutherford. And what did Ernest Rutherford do? He discovered a proton. And he discovered the proton, fine. I forgot to tell you that J.J. Thomson did what they call the cathode ray tube experiment. But Ernest Rutherford did one thing. He bombarded alpha particles. Aha. Very, very funny experiment. It's come to out very, very well. So you need to know this. What did Ernest Rutherford do? He bombarded alpha particles. So when they bombarded alpha particles, what happened? What was the conclusion? We observed that some of these particles, they traveled in a straight line. They traveled in a straight line. We observed that these particles also, they pass through the gold foil undeflected. That is, they pass through the gold foil undeflected. We also observe that some of these particles that in that experiment, when they go to the gold foil, they what? They bounced back. They bounced back. Recall, some passed through undeflected, some what? Bounced back. Some bounced back. Also, you also observe that some were deflected to the negative side of the tube. Some were what? Deflected to the negative side of the tube. Ladies and gentlemen, what are the consequences of those things? What are they? That I want to do here now. What are the consequences? The first one is the fact that, fine, these particles pass through the gold foil undeflected. What does it mean? It means that there is empty space in the atom. You can be asked, this happened. What was the conclusion of this? So for the particles to pass through the gold foil undeflected, it means that there is what? An empty space in the atom. Some of the particles bounce back. They touch the center of the nucleus and they bounce back. Those that bounce back were said to what? To meet a what? A dense center. A dense center. And that dense center is called the nucleus. It's called the nucleus. You also conclude that some of these particles, the atoms, the particles there, they were deflected to the what? Positive to the negative or to the negative side of the what? Of the tube. That is, they got attracted to the negative side of the tube. What does that mean? It means that a positive ray, a positive particle exists, which is called the proton. And those was how it did. Then later on, a scientist, an English scientist called James Chadwick, he carried out his experiment whereby he used magnesium as the reference atom. And what did he do? He concluded about what they call the neutrons. Later on, I forgot to even tell you that before the experiment, what the question of the neutron, a scientist called R.A. Millikan. What I say? Robert Millikan. He carried out what they call the oil drop experiment. And what did he do? In the oil drop experiment, he was able to discover the charge of an electron. And when he got the charge of an electron, using the charge, and what did they also discover before the charge to mass ratio, they were able to discover the what? The mass of an electron. Beautiful things that happened back then. We need to know about the contributions of each of these scientists. Now, going back to that question, they said Millikan's contribution to development of atomic theory in determination of what? He determined the what? The charge of an electron. Option A. Option A. Option A. 4 elements, W, X, Y, and Z, have atomic numbers 2, 6, 16, and 20. Ah, beautiful. Beautiful. That is W, X, Y, Z, 2, 6, 16, 20. Which of these elements is a metal? Which of these elements is a metal? This is atomic number B. What is the second one? Hydrogen, helium. Helium is, this is helium. Hydrogen, helium, lithium, beryllium, boron, carbon. This is carbon. What is 16? 16 should be, because 16, 20 is calcium. Funny enough, 20 is calcium. 20 is calcium. 19, 18, 17, 16. Sulfur, calcium. So the answer is what? Calcium. You know, say we don't even know. What do? You can write this out in electronic configuration. Calcium is 1s2, 2s2, 2p6, 3s2, 4, 10, 12, 3p6, 4s2, 4, 10, 12, 18, 20. So guys, you can see that the atomic shell is s2. That tells us that it is what? It is found in the s block. And that s block is filled with elements that are what? That are metals. So the answer is what? Z. Z is the answer. The next thing there, which of the following statements is true of a proton? Sorry. The diagram above represents the formation of what? You can see there, we have a different orbital and another orbital, but they are meeting together. That is, they are sharing electrons. And what has happened there? That is what they call covalent bonding. Covalent bonding. So you guys, you can see that there are a lot of beautiful questions, which I would like to also continue in the next class. I will still try to bring out a new concept again. We want to see how what we have learned about how we can use it to solve questions. Because fine, you can get the knowledge of everything, but you need to be able to solve questions. So guys, ladies and gentlemen, I really appreciate your time. Thanks for your time. We are going to see in the next class. Thank you.